So you were right, you said x dot, because that's what we have. This is a function of x dot. So what is the higher term? The second derivative, because x dot is the first derivative. So you must now take the second derivative. That's correct. If you know that, you know the energy method, and you never have a problem. You get any complex looking system, you will reduce it to nothing in no time, if you know this. Take the term and the next higher term, and you are done the differentiation. If you know that, this is the easiest way of solving anything. You want to come up with the equation of motion for anything. If you want to use moments, for example, you have to see how is it turning, where is the turning point, and so forth. Energy. There's no need of any turning point or anything. Just say, what is my potential energy expression? What is my kinetic energy expression? Then you solve it this way. Are we together? Yes. So, okay, she told us the final position, but let's get to that position. I wanted to just see if we can think quickly. Because if you are able to think quickly, I won't ask you to be writing all the full things. If you can write that, I know you know it. It's good enough. Okay? And what is it? You take the term, the next higher term. You look at your variable, in this case, x. What is your term? X. Next higher term, x dot. Okay? Similarly, you have x dot. So what is your term? X dot. What is next higher term? X dot dot. That's it. Even if it's in theta. The one for theta, you're going to say theta, theta dot. The one for theta dot, you are going to say theta dot dot. Just that. It's easy, isn't it? Isn't it?
Yeah.
People still want to call it difficult because they want difficult things. Even when I make it easy, they still want it difficult. Hey, serious. So let's differentiate this with respect to t. We are going to say dgx. First of all, this is x dot, by the way. With respect to itself, dx dot. Then dx dot by dt. Can you see that? Because this is an expression of x dot. So we must first do it by itself, x dot. Then dx dot by dt to compensate. So let's substitute this one. We differentiate with itself, so the 2 comes there, 2 over 2 goes away. We're left with mx dot. And this is multiplying dx dot dt. What is this? That's the first derivative of the velocity, which gives us the acceleration, which is the second derivative of the displacement. Are we together? So we are going to say x. And we are done. Now let's take that and put it together. Here. So we have et, which is that. Det by dt. We have done the 2 components by themselves. Now we can write everything together. This part is what? Mx dot x dot dot. Second part plus k x dot. And we have taken the derivative of a constant, so the resultant must be equal to 0. We are looking for the equation of motion, by the way. Can you see it already there? Yeah. We can now factor out x dot. And this becomes what? X dot m plus is equal to 0. Divide through by x dot, it disappears. We are left with Is it clear? Is it clear?
Yes.
So that's the second way of finding. I promised at the beginning, then I forgot and I rushed into other things. But that's the second way of finding the equation of motion. And this is your starting point. Don't go try to do some gymnastics and you don't even know the equation of motion, because you are wasting time. The only thing you can do is cram. But if you can find the equation of motion, then you know. Are we together? Right. So that's the second way of finding the equation of motion. The first way being what? Acceleration force is equal to restoring force. Right. Now we can come back, and we are dealing with a more complex system. It's not just a mass and whatever, but we now want to reduce this to find its equation of motion. Now, when you have something like this, this is a linear motion. So we deal with accelerations and forces. Are we together? When it's like this, on the other hand, it's a rotational motion. Now we are dealing with what? Acceleration, moments. And we are dealing with moments. So our equation becomes the sum of the moments is equal to I. The equivalent of mass in rotation is the moment of inertia. And the equivalent of what? Of acceleration is angular acceleration. If you want, you can first write it this way to show that it's angular acceleration. Alpha. Right? That's your angular acceleration. But in this case, since we are modeling in theta, our alpha is simply the second derivative of the angular displacement, which is theta dot dot. Are we together?
Yes.